All right, so in triangle ABC, prove that angle A is a right angle if and only if the length of the median from A to BC is exactly half the length of side BC. So as you can see, we have triangle ABC, and of course, these points, right, A, B, and C are non-collinear, so that's why I went ahead and drew this circle about those points, right? So let's go ahead and start this proof. And we're gonna, since this is an if and only if statement, we're gonna go P implies Q first, right? So I'm gonna go ahead and use our assumptions. Angle A is a right angle, and AD is a median for the segment BC, right? So, of course, I did draw the circle through these three non-collinear points, and by a theorem we proved previously, we can do that, right? So since A, B, and C are non-collinear, there exists a unique circle that goes through A, B, and C. All right, so now let's go ahead and do angle A is a right angle implies that the measure of angle A is equal to 90. We also know angle A is an inscribed angle, right? So by the inscribed angle theorem, we know that the measure of angle A is equal to half of its corresponding arc, which in this case is arc BJC, is equal to half, so half the measure of arc BJC, right? So this implies that, remember, A is 90, is equal to half of the measure of arc BJC. If we multiply 2 on both sides, we get 180 is equal to the measure of arc BJC. So if BJC is 180, that means it's a semicircle of the circle that contains A, B, and C, right? So this implies arc BJC is a semicircle of the circle containing A, B, and C. Right? So here we go. If BJC is a semicircle, right, that means, this implies that BC is a diameter of this circle, right? All right, so now we're going to use the fact that AD is a median for BC. This implies BD is equal to DC, and both of them are equal to half the measure of BC, right? So if BD equals DC, right, and BC is a diameter, so if we have BC is a diameter of the circle, right, and BD is equal to DC, both of these things together imply that D is the center of the circle containing A, B, and C, right? So what this means is that this implies that A, B, and C are equidistant from a central point. And since we already have that BD is equal to DC, this implies that AD is equal to BD, which is equal to DC, and those are equal to half of BC. So of course, this implies that AD is equal to half of BC, which is exactly what we wanted to show. We wanted to show that the median of segment BC is equal to half of BC, right? So let's go ahead and go the other way now. So now we're going to do Q implies P. So in this case, we know that AD is a median for the segment BC, where AD is equal to half of BC, right? So let's go ahead and use the fact that AD is a median for BC. So that, of course, implies that BD is equal to DC. And of course, that's equal to half of BC. Well, if I have that AD is equal to half of BC, and I have that BD is equal to DC, which is equal to half of BC, both of these things together imply that AD is equal to BD, which is equal to DC. So these points are equidistant from each other, right? So of course, if we were to draw a circle around these points, right? So we can use the same theorem as before. Since A, B, and C are non-collinear, there exists a unique circle that goes through A, B, and C. So since there's a unique circle that goes through A, B, and C, and BD is equal to DC, which is equal to AD, that implies that D is the center of the circle, right? So this implies that A, B, and C are equidistant from D, right? So if they're equidistant from D, this implies that A, B, and C are on circle D, right? They lie on that circle D. So if they lie on that circle D, and BC is a chord that goes through the center, this means that BC is a diameter of circle D, right? So if BC is a diameter of circle D, this means that BJC is a semicircle. Okay? So this implies that BJC is a semicircle for circle D, right? So this implies that the measure of arc BJC is equal to 180. Now, since A is an inscribed angle, we know by the inscribed angle theorem that the measure of angle A, okay, we know that the measure of angle A is equal to half the measure of its corresponding arc, which is equal to half the measure of arc BJC. This implies that the measure of angle A is equal to half of 180, which is equal to 90. Of course, this means that angle A is a right angle. And that is our proof of this really neat problem.